Hello and welcome everyone to my YouTube channel. My name is Mubashir and I am a master's student currently working as a data scientist in Germany. I've created this YouTube channel to share my learning and experiences and contribute to the scientific society by making videos on the latest topics and technologies in my free time. As my first tutorial on this YouTube channel, I have decided to do a very exciting hands-on project on the topic of computer vision, which is of course an application of machine learning. This is the project that I did for one of my courses at the university. I will train an object detection model using image segmentation technique on my custom created dataset to detect very common indoor objects like cups, chairs, lamp, clock, fan, laptop, and others. I have built my own custom dataset using pictures from my camera or images from the internet, so that you will know the essence of machine learning and how easy it is to apply it in your daily lives. In this tutorial, I will start off with the theoretical explanation about the project, followed by code walkthrough, and explain the results and performance of the model. Also, I have made my repository public to share the source code and my dataset, and the links can be found in the description below. So without any further ado, let's jump into the presentation for the overview of the project. The overview of the project is very straightforward. We want to detect objects at a high precision and accuracy using state-of-the-art machine learning technologies. The idea of object detection is inspired by humans, like how humans are able to detect objects present in front of them, and how they are able to differentiate between those objects like a chair, lamp, table, fan, and etc. The concept of detecting objects using computers is not a new one. It has been there for quite some time now, and various machine learning algorithms have been developed over time to perform related tasks. But the major issue was faced while training these machine learning models, since they require a high amount of GPU and memory for processing of the data. However, the advent of cloud technologies has taken care of this issue, since most of the cloud providers offer pay-as-you-go pricing model that allows you only to pay for the compute resources you use, and you can allocate as much GPU power, memory, and storage as you want without any upfront charges. Therefore, a high trend in AI and machine learning has been observed, and now researchers and developers are coming up with more frequent new algorithms for specific use cases and trying to increase the overall efficiency of the algorithms. Similarly, a lot of work has been done in the domain of computer vision, and one of the most common use cases is object detection. You will find a lot of object detection models out there, but how to select the best model really depends upon your specific use case and what problem statement you have at hand. When we talk about a conventional object detector, we refer to passing an image, and the output is generated with bounding boxes across it and a label which says which object is what. And there are a lot of different algorithms for doing this, but there is a new technique called semantic segmentation or image segmentation, which not only detects an object, but also segments it. To elaborate this further, the aim of image segmentation is to label each pixel of an image with the corresponding classes. The process takes place at the pixel level. So in simple words, now, when you pass an image to the model, it will not only draw a bounding box and label it, but also draw a polygon with image mask, similar to what you can see in the picture. This technique provides high accuracy and precision as compared to a normal object detection model. To accomplish this project, we will be using Detectron 2, which is developed by Facebook AI Research Group, and it is being widely used. The great benefit of working with Detectron 2 is that it is an open source, and the implementation consists of high quality, state-of-the-art object detection algorithms using dense pose, synoptic feature networks, and numerous other variants of the RCNN family. Now, moving on to the method we will be using to develop this project. The overall process consists of 5 steps, which are mostly the same to train any machine learning model. Preparing the data, training the data, saving the model, and using that model to make inferences. Here, preparing the data has 2 methods, namely building the custom dataset and registering the dataset, which we will dive in the later part of this tutorial. As I already mentioned, that we will be training a model on our own custom dataset and not taking any dataset from GitHub or Kaggle. The idea is to use machine learning in our daily lives from scratch rather than taking an existing idea and improving it further. To train any machine learning model, you first have to prepare a labeled dataset and train your model with it. This is called supervised learning. Labeling the dataset means you need to provide both the input and the output yourself and pass it to the model so that it can learn from the training data. And once the training is completed, then you provide just the input and the model will be able to predict the output itself. To prepare a dataset for the instance segmentation, you need to create image annotations, which we will see how this can be done. The tool that I have used to annotate my image dataset is LabelMe. Why I have selected LabelMe? There are other tools as well as like LabelMG, Coco Annotate, etc. LabelMe provides a very simple and easy to use user interface, which allows to create and edit polygons around the object. Then it generates a corresponding JSON file with all the information about the image, which we will be using while training the model. So next up are some examples how this can be done in LabelMe, and it's going to be better if I give you a practical demonstration of it. So to open LabelMe, so first you have to install LabelMe, and once you have installed the LabelMe successfully, you just have to open LabelMe like this, and it will open up a very clean, simple to use user interface for LabelMe. Then you have to bring the image of the object for which you need to annotate. So you have to click open. You have to select the image which you want to label. And let's say I'll do this one. So this was the thing that I did just now, but I will try to annotate the chair one to show you how this is actually done. So you have to click on create polygons, and then you have to draw proper polygons across your objects. You need to be a little bit careful while making the annotations. It should be clean and neat. So I'm just trying to do this thing real quick. So I'm missing on so many points here, just to give you an idea that how this thing needs to be done. So yeah. When I'm going to finish this thing, it's asking me to give the name of the label. So I'll give it as chair, and I'll just select OK. The lamp is, I can see the lamp annotation here because I've already annotated this. And when I'll just press OK, so this gives me an annotation for chair as well as lamp. To see the mask, how the masking looks like, I can just click on the edit polygons, and I can just click on this, so it will just give me how the masks are for a chair and lamp. Now, this is for just one image. Once the annotation is done, I have to save my image. I'll just press save as, and with the same name. And yes, I need to replace it. So the JSON, so the annotations are saved in a JSON file, and I will explain the JSON file from the presentation. So this was the process that we just followed, and I showed you that how the labeling can be done. Also, we have seen in a single image, there can be multiple objects. So you can make annotations just like the one that I did right now. So once you are going to save it, it's going to save it in a JSON file. And there are different parameters in the JSON file, like the important ones are label. So the first label that we had was chair, and then it's going to show me the points. Points are basically the area of coordinates that represents a chair, the points that we just make to annotate the chair. All those points are the information regarding the coordinates of those points are going to be stored here. And you can see that from 7, it's going to 152, which means that there are significant amount of points inside it. Then the type of it was polygon. So this was for the one object, and the lamp is the second object. And all the parameters are going to be the same. Lamp, then we have the points, and we have the polygon. There are some additional parameters like the image path. So it's giving me the link to my path, the image data from where I took the data. Then it automatically detects the height and width of the image. So these are all the parameters that are going to be stored in the JSON file. So in this way, we have to label all of our data set. As much, this is just for the one image or one picture, but let's say if you have 500 different images containing 2 to 3 objects per image, you can just imagine that how cumbersome this process can be. But as much data you will provide for training, the better accuracy of the model will be. So I stop here, and I hope this video was useful, and I was able to clarify the topics of object detection and the difference between a conventional object detector and an instance segmentation model. In the next video, I will walk you through the code, how to register the dataset, train the model, and use the model to make inferences. You can find the source code from the repository down below, and the dataset is saved on the Google Drive, and the link can be found in the description below.